Hello everyone and welcome back to Quark Audio. Unfortunately, I'm still having quite a bit of trouble with even my new system with microphones, as you could probably notice in my last video. And well, with the amount of issues that I have had with it, I'm just going to have to spend some time messing with it at some point and just ironing them out. But the show must go on and I still have things to do. So that's what I'm doing today. In my last video, I had done the unboxing of the i807 Red Edition integrated amplifier from Angela-Gilbert Yeung. It's been just over a week since then, since I had actually taken it out of the box, installed it in my system, and I've done, well, 8 days worth of burn-in on it so far. And as of tomorrow at this time, this amplifier will actually be in its new home, in its new system, and hopefully putting a smile on the owner's face in the same way that it has mine over the past week. So, before I shut this down for the final time and remove it from my system and put it back in the package the same way that you saw me take it out, I wanted to give my final impressions on this amplifier and, well, share some of the things that I learned in experimenting with this and just some of the fun that I've had with it. Because I have learned a few things. I've noticed a couple things that I did not expect. And, well, let's just get straight into it. So, as you can see here, I have now 4 glowing blue circles in my system. I have the i807 in my system currently, and the way that I've been running it is utilizing it as the high end of my QLS1 and using it as a biamp configuration with my NAD 218 amplifier for the woofers. For those of you who aren't really familiar with the Infinity QLS1s, they are part of the Infinity models that are known as amp killers, because this specific model can go down as low as 2 ohms in certain frequencies. So it's very high current needing woofers. The high end isn't as bad, but the woofers are really what give it the really low efficiency rating that they have. So I'm only using the i807 as the top end for my system, and then I am using, as I noted, the NAD for the bottom end. So in that specific configuration, this allows me to really focus in on the details and the things that the i807 does well. And that's one of the things that really surprised me, because as you noted before, I was using the C312 preamplifier and a complete separates system. Typically people will say that separates are better than an integrated amplifier, and sometimes in going back or using an integrated, you will notice that you're missing some air or some of the sound stage is missing. I actually had none of that, and I actually was noticing more coherency and a better connection to the music in utilizing the i807. And there's actually a couple of reasons that over the past week that I think that is. One, of course, since I need a high current capable amplifier for the woofers of the QLS, that typically means that there's a lot of output devices. The more output devices you have, the less intimate it's going to be of a presentation, where this only has 4 outputs, where the 218, I think it has maybe 12 or 16. So it has quite a bit to be able to actually have that high current capability and be able to withstand 2 ohm loads for any amount of time. Of course, the i807 is not meant for something like that. It is meant for 8 ohm or 4 ohm loads. And since the top end of the QLS are 4 ohm nominal, that's pretty much perfect. And the power output of around 80 watts into 8 ohms is kind of puts it in a perfect range for what I need for the top end of the QLS as well. So less outputs gives you a more intimate setting with it, better connection to the music because of course you have less in the actual signal path, but I think I was having more coherency as well because of the integration, actually. Angela-Gilbert Yeung's components are, of course, different than any other component, and I think one of the main issues that faces quite a bit of components is actually the power supply and the design of it, or at least the power delivery to the circuits that you're actually using. Angela-Gilbert Yeung uses very high capacitive design, so it's almost like it's running off of battery power. So what do I mean when I say that it essentially runs off of battery power? Well, let's look at a typical power supply and go from there. So if you're looking at your wall outlet and the electricity that you're actually getting from the wall, that is going to be AC. And it's going to be based off of voltage off of whatever your country runs at. So USA is typically 120 volts. Other countries are 240 volts or so. And it is also at a certain frequency. Alternating current, essentially, if you were to look at it in an oscilloscope, you will see a sinusoidal waveform of it going back and forth between positive and negative, and that is done at a certain frequency. Here in the United States, that's 60 hertz. Across overseas is typically 50 hertz. Now, knowing that, as I said, it's going back and forth. DC should be essentially flat, just a constant source. So in a typical linear type supply, you have your wall power going to a transformer that converts it to a different voltage. It is still AC at the exit of that transformer. Then you're going to have your rectification stage, which is typically either just a full wave bridge or diodes, a half wave bridge, etc. We're just going to go with a regular full wave bridge, and then you have your filter capacitors on the other side of that. That rectification stage turns the AC into DC, depending on how you actually have it rectified. If it's a full wave bridge, you're going to have a positive and a negative, and it's going to be a semi-constant DC from those diodes. I say semi-constant because, well, it's going at 50 or 60 hertz, so there's a rise time, and that's all just technical details that we don't need to go into. But that's one of the reasons why you have those filter capacitors. One, they are a reserve for your system or whatever circuit it is supplying. That way you don't have to worry as much about that recharge rate, because if you have a transient or any type of situation where that circuit needs extra current, it can pull it readily from that without having to rely or wait on the power delivery of the rest of the system as much. But as I noted, they're also called filter capacitors because they filter out that 50 or 60 cycle noise that is inherent on the line. Regardless, you're going to have that noise wherever you live in the world because it is AC from your wall. Those filter capacitors help filter out that ripple to get it as close as possible to that flat line and a just constant, steady DC voltage that all of your components, electrical components, actually run off of, specifically your output or gain devices. Angela-Gilbert Yeung takes it to a different level because we have this very large pool of capacitance, and in this ideology it is deliberately much more than it would ever need and for a specific reason. Sure, even if you're looking here at the C312 preamplifier that has over 1 farad, just over 1 farad of internal capacitance, and I connect the SP36 capacitor pack with it, so that makes it close to 5 farads total between those two chassis. Typically, any engineer is going to probably scoff at that because why would you need close to 5 farads of energy for something that is low voltage, doesn't pass much current through it? It doesn't make sense, right? Wrong. Like I said, especially input stages, they love constant voltage. The more stable it is, the better it's going to perform, because it's essentially fully Class A. If you keep it that constant voltage, you're going to have less fluctuation, and it's going to be more stable, and you're going to have less issues and more of, well, what it's supposed to do. And with Angela-Gilbert's designs, that's exactly what the high capacitance does. Regardless the demands of the individual components that make up the circuits, it is never going to be something that is going to affect the power supply as a whole to where it is struggling. And the more capacitance that you give it, the more you make it easy for the component to do its work, because it just has that energy on tap. And even if you have one device over here that is pulling current and another pulling over here, such as left and right, if that energy reserve is large enough, even if they are pulling together, they're not going to have an interaction between the two, because that reserve is just so big. It's a simplistic idea, but it works amazingly, and you just keep adding capacitance onto it, and you can literally hear that in the music to where it sounds more relaxed, more open, because you're just taking it from the wall. You're essentially putting a wall against the wall, if that makes any type of sense. I'll explain that a little bit better here in a second, but it's just the fact that you have that vast, steady reserve of energy. In one of the experiments that I've noticed in playing with the i807 and high capacitance is this I plugged directly into the wall. I have never had my system here with no filtration. Though my power here is much better than my previous home, I at least had a dedicated outlet, and that's what I had done to at least make the best of the power that I had there. Here I have better grounding, but my electricity is worse. I live in a heavily commercial area. We share electricity with other condos in the area. As I said, it's heavily commercial. We're right close to downtown. I have issues with DC, all kinds of things. I've had issues with my system in the past, specifically here before I had Angela-Gilbert Yeung components, where I had a very bad issue of certain times of the day I wasn't able to listen to my system because it just didn't sound right. It didn't sound good. It just sounded thin. It just sounded like it had issues. And the only thing that I really found that helped me out was a balanced power conditioner, where I'm using common mode rejection to try and weed out some of that noise. But even then, I had to put a DC blocker on the front of it. What I really think it was what is happening is the fact we talk a lot about AC, that sinusoidal waveform. If it has enough distortion or noise on the line, the tops of those sinusoidal waves can be clipped off. And that's why a lot of companies really push for that regenerative power supply, where they're essentially using a power amplifier to recreate that sinusoidal waveform, just to reconvert it back into DC. If you have a massive store of energy, that doesn't matter as much. Even if I have terrible power here and it's clipped off, technically, if you look at it on the oscilloscope, that doesn't matter as much, because what that really has to do is with the charging of the system, the charging of your power supply. And a lot of power supply designs in high-end audio are based off of either a lower impedance power supply design or something that has more high current, and that doesn't have anything that can really prevent what happens at the wall. I have a massive power bank here of just DC energy. Even if I have terrible recharge rate or noise at that end, that doesn't matter. That's up the other side of the lake. I still have a lake. Even if it's a little dry coming in, I still have a lake of energy. And that is exactly what I've realized in playing with the i807 over this past week. In this home, I have never been able to plug anything directly into the wall, specifically having to do with top end or anything to do with detail, because I either have noise, there's just times of the day where I can't listen to it, or of course, like I said, I have DC, and I'll have like my toroidal transformer growling. I have had absolutely none of those issues with the i807. The increased capacitance, I believe, has truly helped isolate that from the wall. And it's acting as a battery, and I've even tested it as that, because this amplifier can play for at least 45 seconds after I have turned off that power switch. I'm going to just go ahead and continue here. You'll see the power supply and this slowly dim over time, but this is a power amplifier. Everything in here is currently running off of the capacitors inside of it. I could still put on a song, turn it up, and you would still hear sound coming out of it, meaning right now this is technically disconnected from the wall. And that is exactly what I have heard and observed in the system. Is I didn't find the need for a filter. I mean, Angela-Gilbert still sells filters, and I'd love to experiment with those now. But as it sits, it's not necessarily something that you need going into that, because Angela-Gilbert Yeung's power supplies are built very differently, and they target different things that others don't, that truly allow the components to do their job to the fullest capability. So there we go, it finally shut off the relay, so that is the output side. So funnily enough, I had a video issue as soon as that clicked off, but what I was saying is that was the output relay. So that is the output side of the actual i807. If you were to actually look at it closely, it is still illuminated a little bit, so that means that there's still some residual juice in the input stage. But that entire time that I was talking, for about 45 seconds is what I measured, you could actually still play music through it, completely detached from the wall. And that is something that performance still is enacted when you are connected to the wall constantly. The quality does not change at all from having the switch on or off. So that's why I truly believe that's kind of what is happening here. That massive bank is, in a sense, removing itself from the line, because it filters out the main frequency that is an issue. It creates a constant stable voltage for whatever circuit that it is a part of. And the actual external power supply, or whatever he is using to charge whatever specific component we are speaking on, that is just the constant residual charging system. Though I know it's probably a little bit more than that with the actual power supply for the power amplifier side of this. I mean, you saw the size of the toroids in there, but still, at a lower voltage, lower wattage, it still plays absolutely fine. So, like I said, the more stable you make the power supply for a component, the better it's going to perform. And that's exactly what the capacitor packs do. They are plug and play stability, and it's really fun to mess with. It's really fun to play with. And besides having the i807, having the opportunity to hear one of Angela-Gilbert's higher end integrated amplifiers, I've had a lot of fun experimenting with an integrated amplifier, the high capacitance, and yeah, just seeing what I could do with different components, and seeing where some of the creativity and inspiration comes from for Angela-Gilbert. But It's dark outside. I still have to finish this video, get it edited and uploaded, and well, that was the last time that I powered down this system. It is about to go back into the box, and tomorrow morning I take it to the customer. So that's my time with the i807 Red Edition. For those of you who have stuck around this long, thank you for watching, and hope to catch you in the next video.